Hey there, science fans. Ever wonder how a light bulb lights up or your phone charges? It's all about electrical circuits. Think of a circuit like a racetrack for tiny particles called electrons. These electrons carry electrical energy and they need a closed loop to zoom around. A basic circuit needs three things: a power source, like a battery, a path, like a wire, and a load, like a light bulb. The power source gives the electrons a push, sending them racing along the path. When the electrons reach the load, they give up their energy, making the light bulb shine. Without a complete circuit, the electrons have nowhere to go, and the energy can't flow. That's why, if there's a break in the wire, the light bulb won't light up. It's like having a roadblock on the racetrack. The electrons can't complete their lap. Now, let's talk about resistance. Imagine you're trying to push a shopping cart through a crowded store. It's harder to push, right? That's because of resistance. In electrical circuits, resistance slows down the flow of electrons. Ohm's law helps us understand this relationship. It says that the current, the flow of electrons, is equal to the voltage, the push from the power source, divided by the resistance. In simpler words, more voltage means more push, and more resistance means less flow. Think of it like a water hose. If you turn up the water pressure, more water flows through the hose. But if you pinch the hose, less water will come out, even if the pressure is high. Ohm's law is super important because it helps us design circuits that work properly. By adjusting the voltage and resistance, we can control how much current flows through different parts of the circuit. Next up, we have Kirchhoff's voltage law. This law tells us that the total voltage in a closed loop must always equal zero. It's like a balancing act for electrical energy. Imagine you're taking a hike in the mountains. You start at the bottom, climb to the top, and then come back down to where you started. Your total elevation change is zero, right? You've gone up and down, but you're back where you began. Kirchhoff's voltage law works the same way. As electrons travel around a circuit, they gain voltage from the power source and lose voltage as they pass through loads. The total voltage gains and drops must always balance out, just like your elevation changes on the hike. This law is crucial for understanding how circuits with multiple components work. It ensures that the energy supplied by the power source is used up by the loads, keeping the circuit stable and preventing damage. Finally, let's talk about Kirchhoff's current law. This law states that the total current flowing into a junction in a circuit must equal the total current flowing out. It's like a traffic rule for electrons. Imagine a busy intersection with multiple roads leading in and out. The number of cars entering the intersection must equal the number of cars leaving, right? Otherwise, you'd have a massive traffic jam. Kirchhoff's current law works the same way for electrons. At any point in a circuit where wires split or join, the total current flowing in must equal the total current flowing out. This ensures that electrons don't pile up or disappear, keeping the current flowing smoothly throughout the circuit. This law is essential for analyzing and designing complex circuits with multiple branches and components. It helps us understand how the current is distributed and ensures that each part of the circuit receives the appropriate amount of electrical energy.